All right, good morning. I'm going to be working out our assignment, the day 42 assignment. So start by putting your name up here. And then if we walk through the instructions, it says, let's see, I think it'd be nice to just say what we're going to do. We're going to find numbers. All right, and then I give you the line. First equals int input. Please enter the starting number. So we're going to have two numbers and we're going to find all the prime numbers in between them. And then we need another one of these. We'll say second, the first number, second number. And then I'm going to add a check here. I don't mention it in my instructions. So I'm going to say if first, if second less than or equal to first, this won't work. We need the second number to be larger than the first number. Sorry. And then I'm going to say else. And so the else is our whole program. Okay. Now, step 2 in my instruction says make a count variable. Count equals 0. And then do a for loop with the variable num, N-U-M, that goes from the first number to the last number. So we're going to say for num in range first, comma, second, plus 1. I think in my instructions I said last, but it's fine. Remember, the range call always does 1 less than the second number. So since we want to actually include the second number, we say plus 1. All right, inside, make a variable factors and set it to 0. This is where we're going to count how many factors this variable num has. All right, and now we're going to check. Oh, this is a mistake. This has to be right before that. Oh, no, this is fine. Right. Okay, and now we're going to do a for loop that goes from 1 to num. So for x in range 1, comma, num, we have to say num plus 1 because we want to include num. And we're going to say if num modulo x equals 0. That's saying, hey, if x divides evenly into this num variable, that means we found a factor. So factors equals factors plus 1. And then, so that's going to go through all the numbers from 1 up to whatever number is and check which ones are divide evenly into num. If we find one that divides evenly, we don't print it or anything. We just say, yeah, that's that. Okay, and then after this for loop is over, right here, we say if factors greater than 2, we'll say equals 2. That means it's a prime number. And print num. And then we're going to say count equals count plus 1 because we're keeping track in count of how many prime numbers we found. And then when the main for loop is over, so that's backspacing here. That's we're still inside that main for loop. Backspace one more time. Now the main for loop is over. We're going to print. I'm just for now going to print count, and we'll test it. So my example at the top of the page was 3 and 11. So let's say 3 for the start and 11 for the second, and we should get 3, 5, 7, 11, and that is a total of 4 prime numbers. So I'm just matching, looking at the PDF that I gave you. Yeah, and that's right. So let's fix this up to say it nicely. So that's how many prime numbers prime numbers found between start and sorry, not start, first and second. I'll try it again. I had another sample run on my next page, 1, 2, 3, 4 ones, and then 1, 1, 9, 3. So it found 10 prime numbers between 1,111 and 1193. Yeah, and that's good. And then we can run one more, my other example. It's a million. And this one's going to take, it took 45 seconds last time I ran it, but we'll see. That's because it's processing millions of numbers. In fact, I'm going to add second minus first. This is going a lot slower because it's on REPL. So I'm going to just cancel that and go back to my last example. We'll just go from 1,000 to 2,000. And 135 prime numbers found between 1,000 and 2,000 with 1,001 numbers scanned. I just thought that last part was just a nice touch. I've had that. 1 to 100, 25 prime numbers found between 1 and 100 with 100 numbers scanned. Yeah. All right, that's that.